Hey guys, Mr. T here once again. This is a video about exponential regression. So far, we've only looked at fitting data points to a straight line, so a linear model. Obviously, in reality, linear relationships won't exist between all variables, and one of the more common relationships between variables is known as an exponential relationship. This is just something that we're required to go over as part of your course, and yes, it's fair enough because it's a common relationship you'll find in nature. So an exponential relationship by definition is one in which one of the variables is an exponent. So what do I mean by that? So far, a linear relationship looks like this. Y is equal to 2x plus 3. So the relationship between x and y is governed by this function here. And what you can see here is the variable x is only multiplying. You're multiplying 2 by x. Whereas in an exponential relationship, one of the variables is an exponent. So instead of multiplying by x, you are putting 2 to the power of x instead. So the x variable is an exponent in this particular kind of relationship. So the particular exponential model that we're looking at, because we have looked at a particular linear model, which is in this form, y is equal to mx plus c, we're looking at a particular exponential model that has this form here. Y is equal to a times by b to the power of x. And a and b are constant numbers. B must be greater than 0, and a, conveniently for us, is the y-intercept of the graph. B is known as a multiplier. If you convert this number to a percentage, it indicates how much y is increasing as x increases by 1 as a percentage. It also may indicate a decrease, but as long as you interpret the percentage properly, you'll see what I mean. So let's have a look at some examples here. If you were to see this exponential relationship, what is that telling you? Well, the graph is going to have a crossing at 2 on the y-axis. Y int equals positive 2. So we know it would cross the y-axis here. And 1.56 equals 156% multiplier. That's what B is. Therefore, y increases by 56% every increase in x by 1. So every time x increases by 1, y is going to be increasing by 56%, as indicated by this 156% multiplier, which was 1.56. And this graph would appear like going up in this direction. Okay? This graph, on the other hand, this also has a y-intercept of 2 because a is 2. But it's decreasing because the multiplier is less than 1. Okay, so it's a 0.56. That means 56% multiplier. So instead of increasing, it's decreasing by 56, 100 take 56, 44. Y decreases by 44% every increase in x by 1. So as it's going across the x-axis to the right, it's going down. So it's still got a y-intercept of 2, but this time it's sort of shaped like this. It's starting from the top and heading down to the right instead, unlike the other graph. So what you need to understand here is if the multiplier is greater than 1, so it's a multiplier of over 100%, your line is going to be going from the left down and up towards the right. If the multiplier is less than 1, so it's a less than 100% multiplier, your graph is going to go from the top left and down to the right. Okay, so that's just a a little overview of what the exponential model that we're dealing with, how it acts. Next is the idea of exponential regression. So regression is the process of fitting a model to a set of data. This time, it's the process of fitting an exponential model to a set of data, because so far we've been fitting a linear model to data. It is performed much like a linear regression, but instead you select 0 exp_reg instead of 4 lin_reg instead. So what are the steps? Much like you've done before over and over again, you need to enter your x and y data under stat edit. You need to press stat, go to the right and do the calc tab, and then instead of 4 lin_reg, you scroll down further and select 0 exp_reg, which stands for exponential regression, and the following screen appears. Exp_reg, this tells you the model that it's giving you, and then it tells you the value of a, which once again is the y-intercept of the graph in the exponential model. B is the value of b, the multiplier in the exponential model. Greater than 1 meaning it's going to be increasing, less than 1 means going to be decreasing. And then you still get r squared and r, but no longer are these Pearson's or coefficient of determination, because we're not talking about a linear model anymore. But you can still interpret them pretty much the same way. They indicate the strength of the fit for the model, so you're looking for closeness to 1. Alright? So let's run through a question type that you may encounter involving exponential regression. You might be asked to fit a model to a particular set of data and identify the exponential model that best fits the relationship between the variables. So here you are, x is equal to 1, 2, 3, 4, 5, and the associated y variables are 3.6, 5.7, 9.1, 14.6, 23.3. So, as explained before, the steps are all the same. You need to enter the data into stat edit, so I'm going to do that in the calculator now. Unfortunately, I can't show that on the screen. Just trust that I'm entering the data. So in L1, 1, 2, 3, 4, 5. In L2, 3.6, 5.7, 9.1, 14.6, 23.3. So I've entered the data. Next step, press stat, go to the right on the calc tab, select. Instead of lin_reg, which we've been doing over and over again, you scroll down to 0 and you select exp_reg. Set the x list to where your x data is, L1, y list to L2, and calculate. And what you should find is it tells you what A and B are, and then you can state the model from that. So A, what I put into the calculator was the data, and now exp_reg tells me that A is equal to 2.246 to 4 decimal points, 2460, and B is 1.5961 to 4 decimal points. So what is that telling me? Interpreting, because I need to interpret what A and B mean. A tells us y int is at 2.2460. B tells us multiplier is 159.61%, therefore y is increasing by 59.61% every 1 x increase. So that's the interpretation done. B, use a model to predict the value of y is equal to y when x is equal to 7. Well, I haven't stated what the model is right now. The model is y is equal to 2.2460 times by b, which is 1.5961 to the power of x. That is the model, as determined by exp_reg on the calculator. Now we can use it to predict the values of y. What is y going to be when x is 7? So 2.2460 times by 1.5961 to the power of 7. Do the exponents first because of BEDMAS. 1.5961 to the power of 7. 26.38886329 times that by 2.2460. That comes to 59.2694 to 4 decimal points. So that is what y would be when x is 7. And c, what value of x would be associated with y of 100. So this time we're using the model to find what x is. We know that y is 100. The rest of the model is as written and to the power of x. We don't know what x is. So what's the opposite of timesing by 2.2460? Dividing. So we need to divide both sides by 2.2460. 44.5236 to 4 decimal points, equal to 1.5961 to the power of x. And that leaves us at a point where we can't use algebra really with the level of mass that we're doing to find what x is here. So what you do is use, you don't do that, you don't wiggle the screen, use y equals button to graph, y1 equals 44.5236. So you're going to graph the horizontal line of y is equal to 44.5236. And graph y2 as 1.5961 to the power of x. 1.5961 to the power of x. How do you get x on the calculator? You use the button that looks like x, t, theta, n. And then you find their intersection. The y value, sorry, not the y value, we're finding x. X value is the solution. Okay, so once I've graphed those, I press the graph button. Your standard calculator zoom won't show this properly, where the intersection occurs. So you press zoom button, scroll down to zoom fit, and get the calculator to fit it on the screen for you. And you'll find it draws the line across horizontally at y is equal to 44.5236, and then it draws the curved line going up. Once you've got the intersection drawn on the screen, you can press second and press the trace button. Scroll down to 5 intersect. Tell it where the two lines are. It calls them curves. And then you tell it to guess, and it tells you the intersection is x is equal to 8.1187 to 4 decimal points. Alright, so that is a process of finding the exponential model and also using that model to solve some problems. Hopefully that helps you out, and I will see you in the next video.